So, good afternoon, everyone, and welcome to this lecture. In this lecture, we are going to deal with kinetic theory of gases. In the last lecture, we had seen thermal expansion and we had finished thermal expansion. In this class, we will start with kinetic theory of gases. Now, whenever we think about kinetic theory of gases, we must think about gases as the gases. I mean, every substance consists of a large number of atoms and molecules. Uh, we had seen thermal expansion of solids and liquids. We have not seen the thermal expansion of gases, which we are going to see here. Expansion, how does gas behave when the gas is expanding? Now, the properties of gases are very different from the solids or liquids. Solids have definite size, definite shape. Liquid do not have definite shape, but they have definite volume. Gas does not have definite size, shape, or volume. If you put gas in any chamber, it will occupy the entire volume which is available to it. Yes or no? That means in gases, the molecules are very lightly bound. They can easily move very freely, right? So, the properties of gases, to start off the proceedings, we must understand that the properties of gas are very different from those of solids or liquids. Now, to understand these properties of the gas, we must know three things about the gas, four things probably. We must know what is the pressure of the gas, we must know what is the volume of the gas, and we must know what is the temperature of the gas. Yes or no? Pressure, volume, and temperature of the gas must be known to understand how the gas is going to behave. Do we understand this? Now, whenever we talk about gases, there is a concept that comes very frequently, and that is known as an ideal gas too. So, to start off with um, KTG, we will start with ideal gas, and that is how I normally start. Start with ideal gas. Now, what is an ideal gas? Before going on into an ideal gas, let us try to just go through these small things. If we talk about intermolecular forces in solids are maximum, and in gases they are minimum. But if we talk about something which is known as ideal gas, we take this intermolecular forces as non-existence. For an ideal gas, we take that intermolecular forces as zero, and therefore the potential energy because of this intermolecular forces is also taken as zero. Do we understand this?
Yes.
Every gas has an energy inside it because of its volume, temperature. It's because of its temperature. Every gas has an energy inside it. The molecules have energy. Now we will understand more about this energy, maybe in today's class, maybe in tomorrow's class. But there could be this internal energy of the gas can be in the form of kinetic energy, or it may be in the form of potential energy. Now, whenever we are talking about an ideal gas, we're always taking the potential energy of an ideal gas as zero. So an ideal gas only has energy in the form of kinetic energy of its molecules. Do we understand this?
Yes.
Ideal gas. So if we understand the concept of this ideal gas, everything looks very simple and very promising. I hope you have you know this. You are noting this down. Okay, I'll give you time to note it down. You can note it down. Let me know once you are done. Okay, so ideal gas. Now, ideal gas obviously does not exist because it's an ideal thing. Ideal things um, don't exist. Just to give you a glimpse, I mean, I'm trying to cover both physics and maths here to whatever extent it is possible. So, in physics it does not come, but in chemistry it does come. Your STP and NTP. So you must know what is your STP and NTP. Yes or no?
Yes, sir.
Normal temperature and pressure is 0 degrees Celsius. It is 273.15 Kelvin. Standard temperature and pressure is. I hope you know this. Yes or no? There's a slight difference in temperature. But in chemistry, I don't think whether you understand it. Or you take NTP or STP as same. This is NTP and STP. Every gas will occupy 22.4 liters at STP and NTP. We know this. Yes or no?
Yes.
Hmm. You can note this down. I'm trying to cover everything that can come. Noted it down.
Yes.
Now, when we talk about an ideal gas will follow all gas laws. We will go through those gas laws as well. Don't worry. We'll go through those laws as well. It will follow all gas law at all possible temperatures and all possible pressures. We should be knowing this. Yes or no? We're just summing up everything that we know about an ideal gas, and I will sum it up so you can write it afterwards. First, listen to me, then I will give you time to write. Now, whenever we talk about volume of the gas, it's the volume of the entire container that the gas takes up. The actual volume of gas molecules is very small. We will see all these terms again in KTG, but when we talk about ideal gas, we'll assume that the gas is uniform everywhere. Do we understand this?
Yes, sir.
There is no intermolecular forces for an ideal gas. Whenever we are talking about ideal gas, there is no intermolecular forces between the gas molecules. Since there is no intermolecular forces on the gas molecule, the potential energy of the gas molecules or potential energy of an ideal gas is taken as zero. Do we understand this? So the entire energy is in the form of kinetic energy of gas molecules. Everyone understands this?
Yes.
Now, specific heat. Do you remember the specific heat? C of a gas, of an ideal gas, is a constant and it does not change with temperature. For a real gas, though it changes, and the diagram, and this chapter is all about diagram. So the diagram of an ideal gas and real gas for temperature is like this. All real gases behave as ideal gases at low pressure and high temperature. You must remember this. I'll give you 2 minutes. Two more points are left, and we will understand those 2 points. Everyone knows these points, yes or no? If you don't know, remember them because they are very important for you to remember. These are some points that we have seen. There are 2 more points that you must remember. Now, the expansion coefficient. We have seen the expansion coefficient for solids and liquids. For gases also we have expansion coefficient. There are two types of expansion coefficient for gas. One is known as volume expansion coefficient alpha. The value of volume expansion coefficient is 1 by 273 per degree Celsius. The other one is known as pressure expansion coefficient when the pressure is kept constant, and that is also same. So remember, a gas has two types of expansion coefficients and both have the same value. The last but not the least, remember the gas molecules are very small, so we can assume that there is no effect of gravity on these molecules. Gravity does not have any effect on any of these molecules. I'll give you 2 minutes to note this down. Then let us move ahead and move on to the main point here. And the main point here is the ideal gas equation. And we will solve some question on this ideal gas equation. Remember, whatever we are doing now is common for both what? Both physics and chemistry. But here the only difference would be for chemistry you might be using the value of R as something else. Here we will be using as something else, nothing else. Apart from that, everything is exactly similar. You have to remember the different forms in which you can write the ideal gas. Do you know what are the different forms in which you can write the ideal gas equation?
Yes, sir.
PV is equal to N, capital N R T. Yes or no?
Yes, sir.
Where N is the number of moles, capital N is equal to the number of moles, and R is universal gas constant. Yes or no?
Yes, sir.
P is equal to rho RT by M naught, where M naught is the molecular mass of the gas. Do we know this? Yes or no?
Yes, sir.
Rho is the density of the gas. One more form, PV is equal to small n KT. The small n is the number of molecules or particles. Do you know this form?
Yes, sir.
And K is known as the Boltzmann constant. Do we know this?
Yes, sir.
K is known as the Boltzmann constant. Here we will be using the value of R as 8.3 and Boltzmann constant is R by N. Do we know this? Yes or no?
Yes, sir.
Okay. These are the questions that you must remember, and we'll try to solve some questions based on this so that we are thorough with this ideal gas equation. Have you noted this down?
Yes, sir.
Then comes the first question. Solve it down fast so that we can move ahead. A gas at 27 degrees Celsius has a volume V and pressure P. On heating the gas, the pressure is doubled and the volume becomes 3 times. What is the temperature of the gas? I'll give you 1 minute to give me the answer for this one. Remember, wherever we have to use temperature in physics, in thermodynamics, we always use temperature on the Kelvin scale.
Kelvin square.
PV is equal to nRT, number of moles is remaining same, R is same, so you can write P1 V1 by T1 will be equal to P2 V2 by T2. Everyone understands this? Remember in
Yes,
SI
sir.
units, SI units, nothing else but SI unit. Got this?
Yes, sir.
Okay, let us now move on to this type of question. Remember, in thermodynamics, whenever we are going to go ahead, the number of moles of the gas will not change. So you will not find any questions where the number of moles of the gas change, because gas will undergo a lot of processes. We will call them thermodynamic processes. The only thing that are going to change are pressure, volume, and temperature, not the number of moles. So in most of the cases, number of moles is going to remain same, but you can make some questions on ideal gas. Again, remember, this is a part of chemistry as well. There could be a question of this nature where the number of moles of the gas change. You have 2 minutes to give me the answer for this one. So we know the answer. It is very simple. Yes or no?
Yes, sir.
PV is equal to nRT. Simple equation. PV is equal to nRT. Temperature is remaining constant. Yes or no? Temperature is constant. R is constant.
Sir, temperature is changed, sir. 27 degrees to 52.
Oh, sorry. Sorry. I thought 52. Okay. So PV is equal to nRT. Here everything is changing. The only thing that is constant is R. Number of moles. Number of moles is directly proportional to the mass of the gas. Yes or no?
Sir, pressure and volume also constant, sir.
Pressure remaining same, and it is in a vessel, so pressure and volume are constant. So N into T is a constant, or you can say mass into T is constant. Yes or no?
Yes, sir.
M1 T1 will be equal to M2 T2. Everyone understands this? Yes or no?
Yes, sir.
Paka?
Yes, sir.
Any of these questions can appear in your exam, whether in physics or chemistry. So do them fast. Next one. Read the question, solve it, and give me the answer. Remember what points you have to remember. Vessel is of open mouth, open to atmosphere. Pressure is constant. Volume of the gas is constant. So mass into temperature is constant. Do we understand this, or this is going above our head saying bye bye?
Understood, sir.
Everyone is understanding this? Yes or no? Huh?
Yes, sir.
Well done. Good. Next one. This one comes from the picture. The expansion of an ideal gas of mass m at constant pressure P is given by the straight line D. Then the expansion of the same gas at mass 2m, pressure P by 2 is given by the which line? D option is correct. The expansion of a gas at constant pressure is given by this line. Mass is m. Then the expansion of the same gas at mass 2m and pressure P by 2. Volume versus temperature graph. So just take a deep breath. Everything is there. PV is equal to nRT. R is a constant, so don't worry about R. Or PV is directly proportional to M into T. Yes or no?
Yes, sir.
So V is proportional to M by P into T. Yes or no?
Yes, sir.
And this M by P becomes the slope of this graph. As simple as that. You understand this?
Yes, sir. Yes, sir.
The slope of the first graph is M by P. The slope of
Yes,
the
sir.
second graph is 4 times of that, right?
Yes, sir.
So the 4 times of this is this, and the answer is 8. Remember these simple questions. These are very simple ones. You should be able to find out the answers. Yes or no, no or yes.
Yes, sir.
Okay, these type of questions can appear in your physics, or in chemistry? It's more likely chemistry because this is NTP and STP. In physics, we normally don't use NTP, STP. 2 minutes, you have to give me the answer. So what does the question say? Two identical glass balls are interconnected by a thin glass tube. A gas is filled in these balls at NTP. NTP means normal temperature and pressure, 273 Kelvin. Yes or no?
Yes, sir.
That's it. One of the bulbs is placed in ice, 0 degrees Celsius. Another bulb is placed in hot bath. Then the pressure of the gas becomes 2.5. What is the temperature of the hot bath? Whenever such a question comes, think about the number of moles. The number of moles of the gas cannot change because ding 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 ding. The gas is only getting transferred from one one place to another, and the number of moles remain constant. So N1 plus N2 will be equal to N1 dash plus N2 dash. Do we understand this?
Yes, sir.
Both the things are same, both the volumes are same. Initial pressure P into V divided by R into temperature is 273. Yes or no?
Yes, sir.
Number of moles in the second gas, second chamber will be same. Yes or no?
Yes, sir.
Pressure has become 1.5 but the volume remains same. Yes or no?
Yes, sir.
The temperature of the ice bath is same. Yes or no?
Yes, sir.
When everything is known, yeah, then what is unknown? 1.5 PV divided by R into T. You understand this? Or this is gone about what I'm saying? Bye bye. From here, you will get the temperature. I think the value of temperature that you are going to get is 819 Kelvin. And that happens to be 546 degrees Celsius. This is how you have to do questions of this nature. I'll give you a minute to note it down. Everyone understands this?
Yes, sir.
Let me know once you are done.
Yes, sir.
And this is the next question. Two containers of equal volume contain the same gas at pressure P1 and P2 and absolute temperature T1 and T2 respectively. On joining the two vessels, the gas will reach a common pressure and common temperature. Do we understand this? Yes or no? In the previous case, they were kept in
Yes, sir.
different. One was kept in ice and one was kept in some other hot tub. That's why their temperatures were different. Otherwise, their temperature and volume, the temperature and pressures should remain same. Yes or no? So in this question, you have to find out the ratio of P by T. That is absolutely correct. And the same concept remains. The number of moles N, the final number of moles is N. It will be equal to N1 plus N2. Yes or no?
Yes, sir.
The final number of moles will be given by final pressure P. The volume has become 2V. Yes or no?
2V. Yes, sir.
Divided by the new temperature is T. That will be equal to P1 V by R T1 plus P2 V by R T2, and you get your answer. So remember, if such a question comes, You should be able to solve this. The next question that I'm going to give you, take this one as well. I'm just hoping that such question comes, and then we'll do that one. This one. Two identical containers, each of volume V naught, are joined by a small pipe. Whenever there is a small pipe, they are going to join them. The containers contain identical gases at temperature T naught, P naught. It has to be same. One container is heated to temperature 2T2 while maintaining the other at the same temperature. The common pressure of the gas is P and N is the number of moles of gas in the container at temperature T naught. What is the relation? It's a question from JEE, I think, and it is more than one option correct. Do you understand this? It is more than one option correct. Take your time. I'll give you time. Let me know once you are done. Now, how are you going to do this? It's very simple. The only two things that you know, you only have to deal with the ideal gas equation, right? This is the initial condition. The pink gas has number of moles N naught, V naught, T naught, and the green gas also has the same number of moles N naught, V naught, T naught, and the valve is closed. Now this pink gas becomes like this: N1 V naught P into, because the pressure is common, temperature is also the common pressure is P, but the temperature is different, and this gas becomes this. Yes or no?
Yes, sir.
That's it. You just need to make the equations. P naught V naught by R T naught is equal to N naught. The total number of moles is 2 times N naught. Yes or no?
Yes, sir.
Then now the number of moles, let me write it as capital N. Why I'm writing it as small n? N naught. Here it is given as small n. No. 2 times N naught. N1 will be equal to PV naught by R into 2T naught. Yes or no? And N2 will be equal to PV naught into RT naught. Yes or no?
Yes, sir.
We also know that N1 plus N2 will be equal to 2 times N naught because the number of moles remains constant. From here, you will get the value of pressure. Yes or no? Yes or no?
Yes, sir.
Solving this, you will get the value of pressure as 4 by 3 P naught. You can put this value of pressure in this equation. You will get the... No, you have to put the value of pressure in this equation because you have to find the number of moles in the container at 2T naught. You will get the value of N1, and the value of N1 that you are going to get is this one. So your answers are B and C. Anyone understands how this is done? Yes or no? Same thing. You just have to equate the number of moles of the gas initially and finally. Nothing has changed. Have you noted this down? So no, no, yes.
1 minute.
Let me know once you are done so that we can go ahead. Then we move to this question. At the top of a mountain, a thermometer reads 7 degrees Celsius and a barometer reads 70 centimeter of mercury. At the bottom of the mountain, these read 27 degrees Celsius and 76 centimeter of mercury. Comparison of density at the top with that of the bottom of air. Density of air. I'll give you 2 minutes to give me the answer. And that is correct. Remember here we had to use that equation P is equal to rho RT by M naught. Do we understand this? Molecular mass of air is constant, R is constant. So P is equal to rho RT by M, or I can write rho 1 by rho 2 will be equal to P1 by T1 into T2 by P2. Yes or no? Just put the values, get the answer. Pressure is 70. Temperature is not 7. You have to write it as 280 Kelvin. Do we understand this? Multiplied by, at the bottom, it has to be 300 divided by the pressure is 76. So from there you will get the answer as 75 by 76. Everyone has understood this, yes or no? Comes this question. Similar question has come in JEE many times, and I would like to think about this. This is a question of JEE Advanced, and if you can understand this, it may require some calculation as well, but you can solve this in 5 minutes even. It's a very good thing. So I'll give you this question. This question has a monoatomic gas. An ideal monoatomic gas is confined in a cylinder by a steam-loaded piston. Initially, the gas is at temperature 300 Kelvin and occupies a volume, spring in a relaxed state. The gas is heated by a small coil. The force constant is given. Atmospheric pressure, it is open to atmosphere. So atmospheric pressure is given. Cylinder and piston are thermally isolated. Cylinder and piston are massless. There is no friction. There is no heat loss. Most of the question is like this. No heat loss, no this. Everything is ideal. With all the above assumption, if the gas is heated by heater and the piston moves by 0.1 meter, what is the final temperature of the gas? I'll give you 2 minutes, 5 minutes to solve this question. How are we supposed to do this? The only thing that we need to apply here is P1 V1 by T1 is equal to P2 V2 by T2. Do we understand this? Because the number of moles of the gas will remain constant, the gas is confined. Do we understand this? Yes or no?
Yes, sir.
The initial pressure is only created by the atmospheric pressure because the spring is in its relaxed state. Yes or no? Initial volume is given. Initial temperature is given. Yes or no? Do we understand this, or this is going above our head saying bye bye? Bye bye. Final volume is also given because it is given that, where it is given, that the piston has moved out slowly by 0.1. Piston has moved out slowly by 0.1 meters, 0.1 meters. Yes or no? So, my final volume, my dear friends, become V1 plus area of cross section is given. Yes or no? Area multiplied by this. So, I will just write it as, I'm not more into calculation. This is the final volume that is given. Yes or no? Final pressure. Now you will say, sir, this is open to atmosphere, so the final pressure would be same. Yes, but apart from the atmospheric pressure, the spring is also now pushing it like this. Yes or no? Yes or no? So the pressure of the gas, if I call it the green pressure, the pressure of the gas which is inside, this pressure P2, 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 this pressure P2 will be equal to, one is the atmospheric pressure P naught and one is the pressure because of the spring, and how much pressure spring is applying. Spring applies the pressure which is equal to kx divided by a. Kx is the force and a is the area. Do we understand this? So that is the answer. Your P2 is P naught plus kx by a. Your volume is V1 into AX, V1 plus AX divided by the temperature T2. On the left hand side, everything is known. On the right hand side, now everything is known. The only unknown quantity is your T2. You should be able to get the value of T2. The answer that is given in the sheet is 800 Kelvin. So now just note this one down. Do not calculate it. Calculations can be done at home. Do we understand this, or this has gone above our head saying bye bye? Sir, I'm going bye bye. Sir, I'm going bye bye. Remember, any variation of this question can very definitely come. If this question come in JEE Main, it may not require so much of calculation. One part of it may be asked, or they may ask you the answer in terms of this algebraic values, and then you must know how to solve it. Do we understand this? Yes or no? No, yes. Huh? Okay. Note it down fast. Do not note down everything. Huh? Do not calculate anything. You can do the calculation at home. I have given you the answer also. So you can calculate and find the result at home. Shall we move ahead in life? This is the next question that comes. More questions of this type. A large number of questions of this type will come in the chapter on thermodynamic processes. Here, this is just a beginning, a small chingari, small player. During an experiment, an ideal gas is found to obey an additional law PV square. No, Vp square is constant. The gas is initially at temperature T and volume V. What will be the temperature of the gas when the volume becomes 2 times of V? You have 2 minutes to give me the answer for this one. A very simple question, my dear friend. What will be the temperature of the gas when the volume becomes 2V? Well, Vp square is given as a constant. Remember, in a process, the number of moles of the gas also always remains constant, my dear friends. So we know PV is equal to nRT. N and R. remember, in a process will remain constant. So you can eliminate P. You can write P as nRT by V and put P there. So V into nRT by V square is constant. It basically means what? N and R are also constant. T square by V is a constant. T1 square by V1 will be equal to T2 square by V2. So the volume becomes 2 times, so temperature will become do we understand how I got this? Using the ideal gas equation, apart from the other equation, I have used the ideal gas equation to eliminate eliminate P and get the result in terms of V and T. Do we understand this? Yes or no? No or yes? Have you noted it down, bacha? Comes the next question, the last question in this category, and then we'll move ahead. By increasing the temperature of a gas by 5 degrees Celsius, its pressure increases by 0.5% from its initial value. At constant volume, what is the initial temperature? I'll give you 2 minutes to give me the answer. How are we going to get this? Remember, PV is equal to nRT. That is how things start. It's given constant volume. Volume is constant. Number of moles do not change. R is constant. So I can say in this condition, the temperature of the gas is directly proportional to P. Yes or no? Or I can write delta T by T into 100% will be equal to delta P by P into 100%. Yes or no? Delta P by P, the percentage change. I cannot cancel 100 here because one is given in percentage and one is given in degrees Celsius. So I cannot cancel it. Sorry. 100, 100. This entire thing here, this entire thing here is given as 0.5%. Yes or no? This entire thing here is given as 0.5%. The change in temperature is given as 5 degrees Celsius. So from there, I can find out the value of T. And the value of T that you are going to get, I think, is coming as 1000 Kelvin. Everyone got this? So remember such questions, change in temperature, change in pressure. If you remember this, things are going to be very fine. So this is all that you need to know in gas laws. Now let's break this gas law into 4 or 5 simple law that you have already heard. So we'll go through them quickly. What is the first gas law that you have heard about? The first gas law that you would have heard about would be Boyle's law. Yes or no? What does this Boyle law state? If the mass of the gas and the temperature of the gas is constant, volume of the gas is inversely proportional to the pressure, or you can simply say P into V is a constant. P into V is a constant. Yes or no? That, my dear friend, is known as your Boyle's law. That, my dear friend, is known as your Boyle's law. Now, these are the various graphs that you can draw for Boyle's law. I hope you understand how these graphs are drawn. The first one is a graph between P and V. Do we understand this graph? Pressure is inversely proportional to volume, or volume is inversely proportional to pressure. This is between P and PV and P. PV is constant, so it will remain constant. This is between PV and V or P. This is between P and 1 by V. This is between V and 1 by P. I have seen these graphs come in different ways, and that is why I have given you all these graphs together. Yes or no? Now, P into V is a constant. This is one way you can write the Boyle's law. But there are different ways in which you can write the Boyle's law. The second way is given here. P by rho is a constant. That is also one way of writing the Boyle's law. Yes or no? Do we understand this? So you can remember this way as well to understand Boyle's law. Anyone got this? Yes or no? This is a law at constant temperature. Oops. What has happened? You can see this, yes or no? Oops. What has happened here? Okay. Now we can solve this question. This one. At constant temperature or increasing the pressure of a gas by 5%, what will be the decrease in volume? The answer here is not 5%. The answer here is 4.26%. 4.76% in fact. How do we get this? Now remember here PV is constant, yes or no? So I can write P1 by P2 will be equal to V2 by V1, yes or no? So V2 by V1, pressure has been increased by 100%, so 5%. So P2 by V2 by V1 becomes 100 divided by 105, yes or no? Change in volume upon original volume will become minus 5 upon 105, yes or no? Do you understand what I'm saying here? So the percentage change will become minus 5 by 105 multiplied by 100%. So the answer that you will have is 4.76%. Do you understand this? Shall I move to the next question? This is the next question. This question has come many times in different ways. An air bubble of volume V0 is released by a fish at a depth h in a lake. You know, when you go inside a liquid, the pressure increases. We know this. If you go at a height or depth h inside a liquid, the pressure will increase by rho gh. We know this, yes or no? An air bubble of volume V0 is released by the fish at a depth h in a lake. The bubble rises to the surface, assuming constant temperature and the atmospheric pressure is P above the lake. What is the volume of the bubble just before touching the surface? When the bubble comes on the surface, what is the volume? I'll give you 2 minutes to give me the answer. Option D is the correct answer. So basically what you have to do, temperature is constant, so P1 V1 will be equal to P2 V2. Yes or no? Pressure at the bottom is P0 plus rho gh into volume is V0. On the top, pressure is P0, volume is V. You can straight away get the volume from here. Yes or no? No, yes. So the volume will become more. Everyone understands this? Yes or no? Okay. Here is this question, a very important one because I've seen this question come in many different ways. Give me the answer fast. The adjoining figure shows graph of pressure and volume of gas at two temperatures T1 and T2. Which of the following interference is written interference? Inference is correct. Which of the following inference is what you can infer from this diagram? Now remember these lines that are drawn, they are drawn at constant temperature. These lines are known as isotherms. These lines are known as isotherms. They are drawn at the same temperature. T1 is greater than T2, T2 is greater than T1, T1 and T2 both are equal. Which is the correct? You can just tell me from there. 1, 2, 3, 4. Which option is correct? At the same pressure, you can see V2 is more, P into V is equal to RT, and the option has to be C. Don't write the answer. Just tell me. The correct answer would be C. T2 is greater than T1. Do we understand this? Yes or no? No, yes. The next law that we have to do, this was Boyle's law. The next one is known as the Charles law. Law number 2 is Charles law. Everyone knows Charles law. This is at constant pressure for a given mass of a gas at constant pressure. The volume of the gas is directly proportional to temperature. We understand this? Or you can write it as like this. V by T is a constant. V by T is a constant. You can draw different graphs. These are the different graphs that you can draw between V and T constant, between 1 by V and T. It will be rectangular hyperbola. Between V and 1 by T, also rectangular hyperbola. Between V by T, V by T is a constant, so the graph remains a constant one. Do we understand this? Yes or no? No, yes. You can also write this law, understand this law in a different way. You can write this in a different way in terms of density. In terms of density, you can write it as rho 1 into T1 will be equal to rho 2 into T2. I'll give you 2 minutes to note this down. And let's move ahead and do a couple of questions. This is question number 1. It's a simple, straightforward question just to make you realize that the question which come on this category would be very simple. This is the one. A perfect gas at 27 degrees Celsius is heated at constant pressure to 327 degrees Celsius. Original volume is V. What is the final volume? Give me the answer first so that we can move ahead. Yes. Which option is correct? 1, 2, 3, 4. Option number 4. Temperature increases, volume has to increase. V by T is constant. Temperature has become twice, so the volume has to become twice, and the answer is 2V. Do we understand this? We understand this, yes or no? Next question. A gas is filled in the cylinder shown in the figure. The two pistons are joined by a string. If the gas is heated, where will the piston move? Towards left, towards right, remain stationary, none of these. So what will happen here? See, when the temperature, yes, move towards right. When the temperature of the gas increases, the gas will try to expand. It wants to get more volume. Now, if it moves to left, the cross-sectional area is less, so it has to move towards right. Yes or no? Then only the volume can become more. Do we understand this? Yes or no? If the volume was same, then the question was different. Then nothing would have happened. The piston would have remained here. Do we understand this? Yes or no? Okay. Next question, this one. Remember, all the questions are coming from the same thing. The only thing that is different is in one question they ask you this, in other question they ask you that. This is the next question. An ideal gas at temperature T and volume V, the volume is increased to delta V and the temperature is increased to delta T, pressure remaining constant. There is a quantity delta, which is delta V by delta T divided by V. What is the variation of this quantity with temperature? I'll give you a minute. So how do we do this? Remember, pressure is constant. PV is equal to nRT. If I differentiate this, yeah, I'm doing this the complete way. P into delta V will be nR into delta T. Basically, when you divide, what you get, delta V by V is delta T by T. This is Boyles law, nothing else. Yes or no? Volume is directly proportional to temperature. Yes or no? So now if I write it in different form, delta V by delta T into 1 by V will be equal to 1 by T. Yes or no? This quantity that you see here is nothing but delta. Yes or no? That implies delta into T is a constant. Yes or no? I have written rho. Delta into T is a constant. Therefore, the graph has to be a rectangular hyperbola. And the answer is C. Do we understand this? Yes or no? No, yes. You understand this? The next law, all of you know it, Gale-Essex's law. Some people also call it pressure law. What does this law state? According to this law, if the mass of the gas is constant, the pressure is directly proportional to the temperature. Yes or no? Pressure is directly proportional to temperature, or you can write P by T is a constant. at constant volume and the mass of the gas remaining constant. Do we understand this? Yes or no? No, yes. Again, I can draw all these graphs. This is exactly similar to the graph that we had drawn then for Charles' law. This is just drawn between P and T, P by T and T, and 1 by P and T, and all those things. I hope you understand this, yes or no? I'll give you 2 minutes to note it down. Then comes the simple question. Pressure versus temperature graph for an ideal gas with equal number of moles. Different volumes are plotted. Which is the correct option? V1, V2, V3, V4. It's a very simple question. Many questions have come in JEE based on this. Yes. What about these two volumes? Are they same or are they different? Same or different? They have to be same, yes or no? Same line. Now, you can see the pink wala slope is less and green wala slope is more. The slope is given by this. If I find the slope, it will be given by P by T. Now, PV is equal to nRT. So, P by T gives you 1 by V. That means the graph which has more slope will have less volume. The graph which have less slope will have more volume. Yes or no? Therefore, the correct answer is option A. Do we understand this? Yes or no? No, yes. You understand this? Okay. Two more laws are left. So let us see them. The next law is known as Avogadro's law. So fatafat write it. Avogadro's law. Everyone knows this. Equal volumes of all gases under similar conditions of pressure and temperature will have same molecules. Yes or no? No, yes. Avogadro's law. Simple one. Then the next one is known as Graham's law. You have heard this Graham's law? This is not in physics, this is more in chemistry. Graham's laws of diffusion. The rate of diffusion is inversely proportional to the root of density. Do we remember this? The rate of diffusion is inversely proportional to the root of density, or R1 by R2 will be equal to root over rho 2 by rho 1. Do we remember this? Do we know this? Dalton's law of partial pressure. If you have a mixture of non-reacting gases, if you have a mixture of non-reacting gases, the total pressure exerted by the mixture will be equal to the sum of partial pressure of each gas. Yes or no? No, yes. That is Dalton's law of partial pressure. I hope all of you know this. I will just give you 2 minutes to note it down. Let me know once you are done. And let's move ahead and solve a couple of questions, and that should be it for the day. This is the first question. These questions are more likely to come in chemistry rather than physics, but solve it. The capacity of a vessel is 3 liters. It contains 6 grams of oxygen, 8 grams of nitrogen, and 5 grams of CO2 measured at or mixture at, these are non-reacting gases. 27 degrees Celsius, R ka value is 8.3. Try to get the answer quickly. Solve it quickly. Get the answer quickly. Let me know once you are done. So how are we supposed to do this? We just need to find out the individual pressures. Yes or no? Total pressure P will be P1 plus P2 plus P3. So it becomes N1 RT by V plus N2 RT by V plus N3 RT by V. Basically it becomes you can take RT by V constant to find the number of moles. Mass of first divided by molecular mass of first plus mass of the second gas divided by molecular mass of the second gas plus mass of the third gas divided by the molecular mass of the third gas. Yes or no? You can put these values and get your answer. The answer that is given in the sheet is 5 into 10 raised to the power 5 Newton per meter square. I hope you would be able to calculate and get this answer. This question, same question, not same question, but given in a roundabout way. What will be the answer for this one? A closed vessel contains 8 grams of oxygen and 7 grams of nitrogen. The total pressure is 10 atmosphere at a given temperature. Oxygen is removed by introducing a suitable absorbent. Remove of oxygen. What is the pressure of the remaining gas? Which is basically the pressure of oxygen, which is basically the pressure of nitrogen. So basically they are asking you, the total pressure is 10. What is the pressure of nitrogen? Nothing else. Do you understand this? Yes or no? How are you going to do this? So total pressure is pressure of oxygen plus pressure of nitrogen. That will be equal to RT by V taken common. 8 by 32 plus 7 by 28. You understand number of moles? Yes or no? The number of moles are 1 by 4 and 1 by 4. 1 by 4 plus 1 by 4 becomes RT by 2V, and RT by 2V becomes 10 times. Becomes 10 because this is given as 10. Yes or no? Now when oxygen is removed, pressure is only for nitrogen, and nitrogen pressure is 7 by 28 into RT by V. Actually, the number of moles were same. So both had equal pressure. Pressure of oxygen plus nitrogen were same. So the pressure of nitrogen that is remaining in the container will be 5 atmosphere. Do we understand this? Yes or no? With this, we come to an end of this class. We have done a lot of things in today's class. We have completed the entire gas laws with ideal gas equation. and we have done a lot of questions, and I'm hopeful that one or two of these questions are going to appear in your exam. They might be appearing in your physics test. They might also appear in your chemistry one. So I'm hoping that happens. So I'll wind off this class here. In the next class, we'll move ahead with the actual kinetic theory of gases and see what are its assumptions and how do we work around it. So take care and God bless all of you. Bye bye, everyone.